And in the end, we only going to need to find one factor, or at least at most two factors for this one here, because if I can find two factors, I can divide and break this down into a quadratic. If I know the quadratic, I can always just I can divide to get the quadratic, and I know how to factor quadratics. So an example like this would look like this. So I'm just going to test my factors, my possible factors. My possible factors are plus minus. Maybe I write it over here. This is plus minus 1, plus minus 2, plus minus 4. I should always start with ones, okay? Because ones are really easy. So I'm going to go plus minus, I'm going to go 1, plus 4, plus 3, minus 4, minus 4, and I end up with, this is going to be 8 minus 8, yeah, 0. So I know one of my factors is going to be, I'm just going to move this over, okay. One of my factors is going to be x minus 1. So I've got one already. I really just need to have one more, and if I have one more, I can break this, divide it down into a quadratic. So I'm going to test my next easiest one. I'm going to test negative 1. I don't know if that works. That's going to be 1 minus 4 plus 3 plus 4 minus 4. Okay, so I'm going to end up with, that's going to be negative 8. Oh, this one actually works as well. Now, what just happens that these work, we may have to guess a bit more. Okay, I got kind of lucky. But I know that now that I have two factors, I know that I can break this down into two factors here in a quadratic in blue here. Okay, actually maybe I'll do this quadratic in red because I don't want to mix it up with the blue above. Okay, so I'm going to find that quadratic. Well, how do I find that quadratic? This is where division comes in. So I'm going to do my synthetic division. Okay, so I'm going to set it up. I'm going to start with negative 1. Okay, actually I'm going to move that over here because I think I'm just going to do synthetic division, layered synthetic division in this case. So I've got negative 1, my coefficients are 1, 4, 3, negative 4, negative 4. This becomes, it's going to be 8, it's going to be negative 8, positive 4, negative 4, I get a remainder of 0. Now, if you don't get a remainder of 0 when you divide by one of these factors, there's a problem. There's something wrong here, or something went wrong getting the factors, because we're claiming these are factors, so they should have remainders of 0. Now that I get a remainder of 0, I can actually just do it again. This is a nice thing about factoring, because I can layer. I always get a remainder of 0, so I can always layer my division. So now I'm going to go plus 1. Okay, so it goes 1. I'm going to subtract. 1, subtract, times 1, subtract. So there's my 0, the remainder of 0. So now I've got my quadratic, and these are the coefficients of my quadratic. I know this is going to be x squared plus 4x plus 4, x squared plus 4x plus 4. Well, I know how to factor that. That's going to end up being, and move this down a little bit so I have a little bit more room. We're going to just squeeze this in here. Okay, I'll move this back in a second. Okay, so there's my, I'm going to factor this again. So this becomes x minus 1, x plus 1, and I know this is going to factor into x plus 2 times x plus 2, or x plus 2 squared. Okay, so there's my factored form of this fourth degree polynomial. Now, I've figured out how to factor these polynomials. And this is what I want, because now I can talk about roots, I can talk about solutions to equations, I can graph these things. Okay, so this is something that I wanted to do from the very beginning. I want to know how to factor these higher degree polynomials, and this is how I do it. So the strategy is, we find factors that work using the remainder theorem, we break down the polynomial to a quadratic, and then we factor the quadratic. So here's another one here. We can do the same thing. We're going to guess at our potential factors here. So our possible factors are plus minus 1, 2, 3, 6. We have rational ones as well. Okay, and I'm just going to list them, just not that I'm going to use them, but I just want to make sure I have them. Okay, so I'm probably not going to use these. So plus minus 6 over 2 is again a redundant one. So these are my only two rational ones. So I'm going to test. So I'm going to go P of 1. That's the easiest. 2 minus 1 minus 13 minus 6. That's not equal to 0. So I need to test another one. I think maybe 2 is going to be one I need. I think I need to use 2 in here. Well, let's see. We'll see. Let's try this out. Let's try negative 2. So we're going to end up with negative 16 minus 4 plus 26 minus 6. I think that's going to give us our 0, isn't it? Negative 20, yeah, that's going to give us our 0. So now I have, I'm just going to move these possible factors out of the way. Okay, I'm just going to move them over here a little bit. Okay, now I have got one factor. X plus 2 is one factor. That's the one that works. Okay, so I'm going to highlight that. That's the one that gave me 0. That's that one. Now that I have one factor, I can just break this down into a quadratic. So that's what I'm going to do next. I'm going to break this down into a quadratic. I could keep on guessing, but really I don't want to do that. It's just inefficient. Once I have my quadratic, I'm going to use a plus and subtract 2, negative 1, negative 13, negative 6. So I end up with 4. So I get negative 5. I'm going to end up with negative 10. So I get negative 3, negative 6, 0. Again, if we don't get that 0, you should be asking yourself, you should be asking for where did I go wrong? Because if you don't get a remainder of 0, something went wrong either here in the division or my initial factor, because I have to have a factor. It has to give me remainder 0. Okay, so minus 3. So then I can break down that polynomial even further. I can factor that. That's a quadratic. Again, this is why I'd mentioned before that we need to know how to factor our quadratics. I'm just going to use my little box here. So 2x squared minus 3. I know that diagonal product helps me get the other diagonal. So I'm going to split up negative 5 and 2. This has to multiply to negative 6 and add to negative 5. Well, that's got to be negative 6 times positive 1. Okay, so that will give me the diagonal that's equal to the other diagonal. And then factoring that, I end up with 2x plus 1. And here I get negative 3 vertically, x minus 3. So my factors end up being the x plus 2 that I guessed. I have an x minus 3 and a 2x plus 1 for my quadratic. So there it is. Now I've now started with this cubic polynomial, which was hard to deal with a factored form, which I can get zeros. I can solve an equation now. I can do all sorts of things with this factored form. So this is what I really want to end up doing.